Alright, so my name is Haynes, and this is lab 3 of constant velocity motion. So the observation we're making is the circular lip balm rolling across the table, and the lip balm is moving at constant velocity in a straight line. So our main result is going to be, by Newton's second law, that the net force on the chapstick is 0. So we'll go to tracker, and we're going to see that, the video is of a chapstick rolling across the table. The origin of our axis is in the center of the lip balm, and the axis is slightly tilted up because of the camera angle. The average position that I chose was in the center of the mass because I thought that would give us the most accurate results possible. We need our initial X position to be as close to the origin as possible too, because our origin starts in the center, and that's where we are starting our frames. So that worked out pretty well. The length scale is going to be the length of the chapstick, where if I go to the end you'll see that's what I did. It's 3.9 centimeters, and the mass of the ball is 7.4. Mass of the chapstick is 7.4 grams, but that is actually going to be a little bit greater because I wasn't able to account for the metal around the balm itself, so it's going to be greater. But for this lab we don't have to worry too much about that. It doesn't change the results too much. So we'll go back to this. We need certain pieces of information to be able to construct our computer simulation. We need the mass of the object, which is 7.4 grams. We need the initial X position, 9.006 meters, and we need the average velocity, which you can see I calculated, and it's going to end up being about negative 0.104 meters per second, which makes sense because the chapstick's not going very far. It's going to be a very low velocity, and it's moving in the negative X direction, so the velocity is going to be negative. So our net force again is 0. So then we'll go to Python. Here we can see that I included everything. Here's my equation. Final velocity equals initial velocity plus force divided by mass times delta t, and then the new position, final position, equals initial position plus velocity times delta t. So and I adjusted the visualization a little bit, so we'll go ahead and run the model, and we can see that the model does look pretty similar to the simulation does look pretty similar to the model. It's a negative velocity, it's moving to the left, and it takes about 1 second, and it all looks pretty good. So now we can look at the comparison of the graphs. Alright, so now that we've looked at our data from the simulation, we can compare our data together. So here's the data from the tracker model, here's the data from the simulation, and here are them together. So you can see they're almost completely similar. The blue diamonds are the tracker model, the red squares are the simulation. And the tracker model really does follow the simulation almost exactly. There is a little bit of sway here and there, like right here, but that's probably just due to user error. That's me, putting the point a bit off from where it should have been. But, I mean, for the most part, it's almost exactly the same. So now we can look at the what if and the what does it mean question. So what if the origin changed? If the origin changed, the initial position value would be different. The velocity wouldn't change because it's still the same change in position over change in time no matter where the origin is, but the origin could affect the position vector. As in, if the position of the origin was above the lip balm, then suddenly the position vector has a y component of position. Now the y component of position wouldn't change. It would be the same initial and final, but it would still have a y component. So, that would have to be considered. But as far as the velocity, it wouldn't change. So now we can talk about what does it mean. Can we add up the pushes and pulls of force? Yes, we can. We know that the lip balm wasn't moving in the y direction. It wasn't moving up and down, so we know that the normal force of the table canceled out with the force of gravity. There was no force in the z direction, and because it was moving at constant velocity, we can assume that there was no net force on the lip balm. And of course there's friction force on a table, but that wouldn't make much of a difference in the small time frame that we were recording because it still moved at a constant velocity. So we know that the pushes and pulls of force canceled out, and we could look at them and add them up. So it was all good. So thanks for listening to my lab.